Hello, my students. This is a brief tutorial reviewing the operation of eudiometers. Eudiometers, which honestly in class we are usually using gas collecting tubes, are utilized as an indirect way to measure the pressure of the gas. Whenever we have a collected gas, it's quite easy to get the volume, to get the temperature, often even to get the mass. However, how do we measure the pressure, especially without losing any of our gas? In lab, they are long test tubes that look a lot like our burettes. They have graduations on them, and they're open at one end. Usually, we are filling these with water, completely overturning them, putting them beneath the surface of a beaker of water, and then allowing the opening to be released, and this will be filled completely with water then. Usually, you're doing some kind of reaction and then trapping the gas and forcing it through rubber tubing into the eudiometer. Through water displacement, because gases have mass and volume, of course, low density will cause them to bubble up. They then will collect and displace the water and will end up with an amount of gas inside of our eudiometer. To measure the temperature, usually, honestly, we're at room temperature, but usually we're going to measure the temperature of the water. We can get the volume by reading the graduations on the eudiometer. So again, how do we get the pressure of the gas? Well, with a barometer, we can measure the pressure of the gas on the outside. So if I can go ahead and draw the situation that we'll have. Let's just say our reaction produced enough gas that the liquid level inside and outside are the same for the eudiometer. We will know the pressure of the atmosphere from the barometer reading. Let's go ahead and say that that's 745 millimeters of mercury. We look at the liquid level inside compared to outside. If the liquid level inside is the same as outside, that means the pressure of the gas or gases inside is equal to the pressure of the atmosphere. So the pressure of the gases on the inside would be 745 millimeters of mercury. Why do I write gases? Well, whenever we have liquid water, we also have water vapor. So whatever gas we were trying to collect purely, because water is just nice and safe and accessible to use, well, we're not only going to have the pressure of the pure gas, but also the pressure will be due to the presence of water. We will be able to determine the pressure of our gas then by simply taking atmospheric pressure and subtracting away what we would call the partial pressure of the water. This is a gas mixture, which is a result of just the adding of the pressures of our different gases. So how do we know what the partial pressure of water is? It is based upon the temperature. That's why I suggest taking the temperature of the water here, because that will dictate the amount of water vapor that we have. That can be found within a table. These are easily accessible. So if we're working at room temperature, then the partial pressure or the vapor pressure of water will be 24 millimeters of mercury. And so, to get the pressure of the gas, all that we do is take our 745 and subtract away that 24. And notice I claimed the value that was millimeters of mercury, and we'll get the pressure of the gas. But how rarely is it that we will collect a gas so that the liquid level inside and outside are the same? That's quite a rare thing. So let's talk about the normal situation. where we're collecting either above or below the liquid level. And this is water. Well, we can still say, and start with a comparison to the atmospheric pressure. However, the liquid level inside is higher than outside. So that means the pressure collectively of these gases is less than the pressure of the atmosphere, because the strength is just not there to be able to battle and push down in comparison with the atmospheric pressure. All that we need to do, because our barometer reads the strength at being able to combat gravity, we can look at the height difference of the inside and the outside. All right. So the pressure of whatever gas, we're going to start by comparing it to the pressure of the atmosphere. We know because we're collecting over water, we'll have water vapor there. We need to always subtract away that presence due to temperature. Since there is a height difference, we will subtract that height difference away, because the pressure of the gas is weaker than outside. However, we've collected over water, and this will be millimeters of mercury. This will choose millimeters of mercury, and this will be millimeters of water. We know mathematically we're in a quandary. Here's where we will rely on the density difference between water and mercury. The density difference is 13.5 grams per milliliter of mercury as compared to water. So, if we would have a height difference, let's say, of 35 millimeters of water, and we would measure that with a ruler, if we divide that out by 13.5, for every 13.5 millimeters of water of height, that will be equivalent to 1 millimeter of mercury. That will then convert to millimeters of mercury. So, whenever we're over water, to get the pressure of the gas, we'll get the pressure of the atmosphere. Here, because our liquid level is higher than outside, we'll subtract the height difference, and we always subtract away the partial pressure of water. However, we're going to need to divide this by 13.5 to get our units to cooperate. If the liquid level would be below what it is on the outside, well, that means the pressure of the gas on the inside is greater. So we would add the height in that case. So our equation then is the pressure of the gas equals the pressure of the atmosphere, subtracting away the partial pressure of water due to temperature, and then we'll add or subtract the height difference if there is a height difference. If we've collected over water, we must divide that height difference by 13.5. Now, there is a situation where we could be collecting our gas over mercury. Because of safety reasons, of course, practically we would never do that. But in that case, all that we would need to get the pressure of the gas would be to compare the pressure of the atmosphere and then add or subtract the height difference. Because it will be mercury, so this will automatically be millimeters of mercury. Liquid mercury has what is just go ahead and assume to be a zero vapor pressure. So thereby we do not have to add or subtract any kind of vapor pressure of mercury. So if it were over mercury, this is our equation. But most commonly, of course, we're collecting over water.